Alright, so now that we're able to identify linear functions or build a linear function out of given information, once we have said information, the question is, oh, what sort of use can we make out of that? So the goal of identifying the explicit form for any function is to concretely establish a relationship between the input or output variables or the independent and dependent variables, in our case, x and y. So if we look here, we have a picture of uh, a linear function on our Cartesian plane, and for every x value, we should input out some sort, or should output some sort of y value, right? If I have x values here, that should output to y values here. So given some x value, I should be able to find some y value, and I should be able to go backwards as well, right? If I say, oh, here's a y value, I should be able to find the x value that corresponds with it, right? Here's a y value, I should be able to find the x value there as well. So our y value here. Now, so let's go ahead and just do a few examples of this. First, let's give this let's give this linear function some sort of form. Let's say it's minus 2x plus 5. Alright, and then let's ask ourselves some questions briefly, such that when let's say when x is 3, what is y? When y is negative 8, what is x? When x is 0, what is y? And when y is 0, what is x? Right? Our goal is to be able to take x values and correspond to y values and vice versa. Alright, so let's go ahead and start with these. So when x is 3, what's y? What we know is that this is our relationship between our variables, right? And what we also have is that in this particular instance, our input x is 3. So we can evaluate our x value at 3. And so that gives us a y value of minus 6 plus 5, which is negative 1. So when x is 3, y will be negative 1. Alright, for the next problem, when y is negative 8, what is x? Now, we look over here, we don't know what x is, so that's left alone, but we do know that y is negative 8, right? So we put negative 8 in for y, we leave x alone, and now we're going to see what x is. Well, what we know is that minus 13 is minus 2x, so x itself is 13 halves. Alright. So far so good. When x is 0, what is y? This is just a reiteration of the first version of these problems. So once again, we're going to evaluate x at 0. And what we'll notice is that that just gets rid of the entire first term, and we're just left with 5. And no surprise, right? That is our y-intercept, which occurs when x is 0. So when x is 0, the y value is 5. when y is 0, what's x? Well, once again, what we do is we evaluate what we know, and then we solve for what we don't know. So 0 is equal to minus 2x plus 5. Minus 5 is equal to minus 2x. X is 5 halves. Now, this is all done algebraically or arithmetically, but remember that what underlies all of this math here is geometry, right? We're talking about lines. So everything we found here, we should be able to talk about in some sort of geometric terms. So let's go ahead and talk about what's happening here. Let's say y is equal to minus 2x plus 5. That's what we were talking about, right? Sorry, minus 2x. Now, our first of our questions was, what happens when x is 3? Right? If x is 3, then the corresponding y value that lies on our line is 3, negative 1, right? When x is 3, y is supposed to be negative 1. And that's exactly what we found, right? So that coincides. Let's go ahead and follow up. When y is negative 8, what's x? So this is a similar deal to before. When y is negative 8, it looks like our x value is 6.5. Now, what we had said before is that it's 13 over 2, and what shouldn't surprise us then is that 13 over 2 is, in fact, 6.5. Great. So, let's go back and take a look at our other scenarios. We also asked, what happens when x is 0? Well, when x is 0, y is 5, which is the intercept, which is consistent with what we said here. And lastly, our final question is, when y is 0, what is x? So when we ask, when y is 0, our x value coinciding with that is 2.5. We had, wrong thing here. We had claimed that it was 5 halves, and once again, it shouldn't surprise us to see that 5 halves and 2.5 are the same. So, to summarize, once we have the description of a linear function, you can take x values and transform them into y values, or y values and transfer them into x values at your leisure, and you can find this correspondence either algebraically, as we did initially, or geometrically, as we've done with Desmos here. Alright, once again, if you have any questions, please let me know. Thanks for watching. I'll see you in the next video.